you have a force here at mid height. That is your surcharge punya. So that's your Fs, and then you have your FC, that's FC at mid height, surcharge. And then you have your Fs. Fs is 1 meter down. And then you have your Fw, your water, which is 0.67. So you have these three forces pushing. You have these three forces pushing on your retaining wall, and it will cause the retaining wall to do two things. It will cause the retaining wall to rotate. It will cause the retaining wall to slide. Okay? It will do both things. All right? So now we have to get the moment. What is that moment? How do you calculate the moment? Well, you have your lever arms already. Okay, now, so to get the moment, we first need we have one height missing, that one. The thickness of that base. So normally the thickness of the base, we follow the stem. If the stem is 200 thick, the base, we make it 200 thick as well. So make it 200 lah. Okay. So now you can basically calculate your, so now basically you know your moment lever arm. So you take moments about at the bottom of the base, you can calculate your moment. Okay, your rotational moment. So your moment is okay. How do you calculate the moment? I don't want to show you. I want to ask, how do you calculate the moment? Now, think about it. You take a good look at this. What is this actually? How do you design this? Okay, so this is what I was gonna tell you earlier, right before we started. So now is the correct time to ask, I think. If you design this retaining wall, how would you design it? So if you think about it, this retaining wall is actually now, this retaining wall, can I turn it around? I can turn it around. I can turn it around to make it clearer. Basically, I turn, I just rotate. I rotated the retaining wall. I rotated the retaining wall by 90 degrees. And then you have force here, force here, force here, right? Yeah. Yeah. What does that look like to you? So
beam
basically,
column.
Correct. A beam with column. Your base now becomes a column. Your stem now becomes a it's actually a cantilever beam. Your stem is actually a vertical cantilever beam. Yeah? It's actually a beam cantilevering from a column. So now, to calculate the moment, you assume the whole thing's cantilevering lah. Yeah? So, to calculate the moment, you treat this as fixed support, you take that as a cantilever, and then you take your load here. Cantilever. Now do you know how to calculate the moment? Yeah, so this is what WSC. Okay, so this is FW F S FC. This distance is 0.67. This distance is 1. This distance is 1.5. Huh? Very easy. Wait. Sorry, it's not. I forgot. you have the 0.2 here. To the support is actually 0.2. Another 0.2. So all of them, you have to add 0.2. You have to add 0.2 to go to the end of the support of the beam. Okay? So moment, you treat it as cantilever beam. Moment is FW times 67 plus 0.2, 0.87 plus FS times 1.2 plus FC times 1.7. Okay? FW is what? What's the value of FW just now? FW 6.6. So FS to 23.8 times 1.2, yeah, plus FC 4.95. There. That's your moment. You treat it as a cantilevering beam. Yep. So 6.6 times 0.87. 6.6 times 0.87, 5.7 plus 23.8 plus 4.95, 8.4. So that's your moment, yeah? 0.7 plus 20.6 plus 8.4. There, your moment is 42.7. Okay, that's moment. Now, you also have shear, yeah, because as I told, as you told me, this is actually a cantilevering beam. So FW, FS, and FC is causing shear there at the support, yeah, causing shear. It's causing shear there because all these forces have to get transferred into the column as shear. So the shear force is FW plus FS plus FC. Which is 6.6 plus 23.8 plus 4.95. Yeah. 6.6 plus 23.8 plus 4.95. 35.35, so 35.4. There. You have a moment, you have a shear force. Do you know how to design the wall of the retaining wall now? You design it as a beam. You just design it as a beam. Yeah, so it's basically a cantilevering beam with that moment and that shear force. So let's do the fracture design, okay? So the in other words, let's deal with the moment first. So we deal with the moment first. Okay? Okay, so beam design. For moment fracture, what do you start? How do you start? You always start with this formula, K equals to M over B D squared FCK. Yeah. If you look back for the beam design, the flexural design part, flexural calculation part, bending, you always start with this formula first. So moment is 42.7 kilonewton meter. We have to convert to Newton millimeter, so times 10 to the power 6. B, okay, B, okay, BD. Okay, this one I need to explain a little bit. What is the B, what is the D, okay? So, a wall. So the retaining wall looks like this. Okay, in cross section looks like this, but in 3D, it's actually a continuous wall. Yeah, your retaining wall is actually a continuous wall. It's actually a continuous wall. All right. So in other words, you design it like a slab. A slab is continuous as well. Okay. So the way you design it is like a slab. You take you design for 1 meter segment. Okay. Whatever reinforcement you have, you spread it all over lah. Every meter you have the same reinforcement. Okay. So the B you take 1,000. Yeah, 1 meter. Okay, and then the D. So I told you just now the thickness is 200 of the wall, but that is the H, the thickness of the wall. Okay, you obviously will have reinforcement. So it's gonna bend this way. So reinforcement is gonna be here. You need to have some reinforcement here. Okay, and you need cover. So let's say we've done the cover calculation 40. So therefore, your D is your thickness, 200 minus the cover, 40. So 160. Okay. So your D is 160 squared times FCK 30 just now, given in the question. So that 42.7 divided by 1000 divided by 160 squared divided by 30, concrete grade. So no, only 2. 1, 2. No. 0.06. 1, 2. Yeah, 0.06. Okay, which is less than 0.167. Therefore, no compression reinforcement required. Okay, then you can calculate your Z, which is D times 0.5 plus square root 0.25 minus K divided by 1.134. So D is 160. 0.5 plus. All this formula you should know. I've covered it before. Okay. Minus K is 0.06, 1.134. So all these formula are actually from your beam design, from your flexural design exercise example that I covered at the beginning of the course. Okay, they are the same formula. Okay, bending is bending. Doesn't matter whether it's column, whether it's beam, whether it's a retaining wall. Bending is bending. You use the same formula. You use the same bending formula. Okay, okay. So here. So what is this? Okay, so 0.06 divided by 1.134. 0.25 square root plus 0.5, 0.94. 0.944 times the 160. So if I multiply this by 160, it's 151 millimeter. Okay, so my Z is 151 millimeter. So area required is M divided by 0.87 FYK Z. Yeah, yeah, I think so. Yeah, Z. Yeah. Okay, so for 2.7 times 10 to the power 6. So all these steps, if you don't know what I'm talking about, you go back to the earlier classes. Okay? I've gone through the exact same formula. Okay? Z is 151. So area of reinforcement required. Not much. 650. But this is per meter. Yeah, per meter. So every meter width of wall, you need 650 millimeter square of reinforcement. Okay. So that's the flexural part. Now shear is shear, you've done it before. Okay. So shear, you've done it before. It's the exact same type of calculation for shear. So have a look, go back and revise your shear because there's going to be a test in 2 weeks' time as well. Okay. So the shear part, you just go back and revise the shear calculation. Okay, it's the same calculation. All right. Okay. Obviously, this retaining wall design, I'm teaching you the structural design calculation. This is the structural. In other words, how much reinforcement you need to put in, how thick the wall needs to be. There are two calculations that you need to do. For retaining wall design. Two types. I can't spell properly after the New Year. After Christmas and New Year. Ate too much and drink too much. Okay, retaining wall design. There are two types of design that you need to do. The one that I taught you is structural. Structural, the wall itself. The one that you learned in geotech is, well, obviously the geotech. Yeah. You also have to do geotech check. This one I'm not going to teach you. I'm teaching you structural part. Geotech, you have to refer to geotech lah. Okay. What are the but just for your revision, what are the geotechnical checks that you have to do for the retaining wall? What are the geotechnical checks that you have to do for retaining wall? Have you done retaining wall design in geotech?
Yeah.
Yeah. So what are the checks that you have to do? Geotechnical checks.
Sliding.
Correct.
And overturning.
Sliding. And overturning. Yep. And then there's FOS, right?
Yes.
Yeah. Overturning FOS is normally 1.5, I think. Sliding FOS normally 2, right?
Uh-huh.
Yeah. Okay. That's one. And there's another check you have to do. The ground bearing pressure, right?
Yes.
Yeah, make sure the ground, if it's bending, oh, like this. Wait, let me draw my sliding up here so that it doesn't confuse. Yeah, sliding. Okay, sliding. Yeah, so overturning and sliding. But there's also one more check that you have to do. It's the, because when it overturns, what's going to happen is it's going to put a lot of downward force in the soil at the right hand side. At the right hand side, it's going to put a lot of force into the soil. And then as you go towards the left, that force reduces because it overturns. Yeah, you have to find out where the center of gravity is. Okay, but it's going to look like this. Okay, so you have to check. It's going to cause a bearing pressure on the soil. So that pressure there, whatever the value is, you can calculate. You have to make sure it's less than the soil strength. Okay, you have to make sure it's less than the soil strength. Otherwise, you will get excessive settlement. Okay, in other words, your retaining wall is going to start rotating, moving. Okay, it's going to start failing basically. Okay, so these are the geotechnical checks. What I'm teaching you in this course is the structural check. So, okay, so when you do retaining wall design, you have to do both checks, structural and geotechnical. All right. Okay, so that about covers it. That about covers it for retaining wall design, the structural part. Okay. Any questions?
Is this not in exam, right?
I don't know. uh, you better learn it first. Okay, better learn it. I will let you know about the exam during the revision class. Okay?
Okay, doctor.
Yeah, belajar saja. This is very important, especially when you start working. Okay? I will let you know about the exam during the revision class in 2 weeks' time, maybe. Yeah, after the shear, after test three. After test three, I will go through the exam with you. Okay? I'll give you a short revision class on what to expect during the exam. Okay?
Okay.
All right.
Sorry, doctor.
Yep.
I just have a question. For FS, how is the value 23.8?
Or FS, huh?
Yeah.
Let me see. But did I calculate it wrongly? I don't know. Are you asking me how I calculated it, or are you saying it's wrong?
Um, I don't want to say it's wrong, but isn't it supposed to be multiplied by 1 meter only?
No. Okay, so FS 23.8, right? You're asking this
Yes.
one, right?
Yeah.
Okay, it's okay. I'll go through with you again. Oh. Okay, now, so this 1 meter, so very good question. Yeah, thanks for asking. So this 1 meter is the height at which the Fs reacts. It's a resultant force. Where the resultant force is, it's a location of the resultant force. It's 1 meter from the bottom. Okay. Now, Fs itself is the resultant force. To get the resultant force, maybe I write it like this. So Fs is the area of the triangle. It's not clear. Fs is the area of this triangle. So you try to calculate the area of a triangle. What do you get? So the area of that triangle is what? Area. So the area of the triangle, now the bottom is 15.84. At the bottom is 15.84. So the area of the triangle is 15.84 times the height, which is 3 meters. And then because it's a triangle, you have to divide by 2. That's how I got it. But first of all, do you agree? The area is 15.84 times 3 divided by 2?
Yes, doctor.
Okay, yeah. Okay, so we try to do that. Yeah. So I got 23.8.
Okay, doctor. Okay,
Yeah.
thank you.
Yeah. So Fs is area of the triangle. Same as the pore water pressure. Fw is the area of that triangle. And then for the surcharge is the area of this rectangle for F. For the surcharge is area of this rectangle. Okay. That's all. So yeah, that's how I got it. Okay. But yeah, good thing you asked for clarification. Yeah. Anytime you are not sure about anything, you should ask. Well, I'm still here. Rather better than you go back, you do revision, and you start guessing. Is that right? Is that wrong? Yeah, might as well ask me now. Okay, any more questions? Wow, everyone else understand, yeah? No questions from anyone else? Zul, you okay?
Okay, dokter.
Semua faham?
Um,
Oh, okay lah. All right. Okay, so in that case, okay, that's it lah. That's it for retaining wall design. So just to recap, for next week's presentation, we will take turns group by group randomly. Okay, there's not going to be a sequence. I will call each group randomly to present. Some groups will present on Thursday, some groups will present on Friday, but all groups have to attend the presentation. Okay, on both days. Okay, so let's say on Thursday. Let's say on Thursday I call group 1. Example. No. Let's say on Thursday I call group 5. Okay, so on Thursday presentation I call group 5 to present. All the members have to be there, but you choose one person to present. Okay, all the groups you choose one person to present, to represent you, but everyone has to be there. Even though the group leader is presenting, everyone else has to be there. Okay, I will ask. So the presenting person, before the presenting person presents, I will ask him who is in his group, and I will take attendance for that group to make sure everyone's there. Okay, if someone's missing, then that person will not get any marks for presentation. Wait, presentation heavy, 10% for presentation. So make sure you're there. If I call your name, you're not there, you lose the 10% straight away. Okay? So only one person needs to present, but all the group members have to be there. You have 5 minutes to present, and then you have about 2 minutes for Q&A. I will ask 1 or 2 questions. During Q&A, anyone can answer. Doesn't have to be the presenter lah. Okay? If the presenter cannot answer, someone else in the group can help to answer. Okay? So about 2 minutes for Q&A, and then 1 minute to switch between groups. Okay? To switch to the next group. All right? So that's the format of the online presentation. Okay? And then the test will be on shear design. The strut and tie method very similar to what I taught you during class. Okay. All right. So that's it. If there are no more questions, I'll end the class here. I will see you for the presentation next week online. Okay. Thursday, yeah? We start on Thursday. There's gonna be 2 sessions, Thursday and Friday. Okay. I'll see you on Thursday first. All right. Where's my Google Meet? Where's my Google Meet? All right. So have a good weekend, guys. Do you have any more class after this?
Yes. Yes. Okay.
Online juga?
Online. Yes.
All right. Okay. Have enjoy your class and then enjoy your weekend after that. All right. See you next week.
Okay. Thank you, doctor.
Take it up there.
Thank you, doctor.
All right.